Alright, today I just wanted to go over basically the 6 types of triangles, how they overlap and how they relate to each other. So this is kind of a tough thing, but let's see if I can explain it. Alright, so we have so there's right, obtuse, and acute. These triangles, these 3, are based on their angles. Okay? So a right triangle has a right angle and then 2 acute angles. Now it has to be 1 right angle and 2 acute angles because a triangle, all of the angles have to add up to 180. If there was a triangle that did not add up to 180, the 3 angles did not add up to 180, it would basically not connect. So basically, if you had 2 90-degree angles, right, it would be something like this, and it would just be, one side left over, right? Because this would be 90 plus 90, this would be 180, and these would not connect. So for it to be a triangle, it has to, all 3 of the angles have to be 180. Okay, so that means a right angle is 90 degrees. And as long as these 2, they don't have to be the same, but as long as these 2 add up to the other 90, right? Because 90 plus 90 is 180, then that will work. An obtuse has one angle that's bigger than 90, right? Obtuse is bigger than 90, and then 2 angles that are smaller than 90, 2 acute angles. And an acute is 3 angles that add up to 180, and they're all under 90. They're all acute angles. Now, I wanted to just point out one cool trick that a teacher taught me to remember what is obtuse and acute, which one's bigger than 90 and which one's smaller than 90. So obtuse is like a tuba. Obtuse, and it's like a tuba. And tubas are big. And then for acute, it's a cute little angle, right? It's a cute little angle. So acute is smaller, obtuse, like a tuba, is bigger, okay? Then we have 3 other types of triangles. These triangles are based on the length of their sides, okay? So the first one is an equilateral, and that means that all 3 sides are exactly the same length. The next one is isosceles, and that means that 2 of the sides are the same length and 1 is different. And then there's scalene, which is all 3 sides are different. Okay? And these lines are just representing, so if there's 1 line through each of the sides, it means they're equal. 1 line here means that they're equal, and then this 2 means that it's not equal to these. And then 1 line, and then 2 lines, and then 3 lines means that none of them are equal. Okay? Now, the interesting thing is because these types of triangles are measuring different things, angles for the top ones and length of the sides for the bottom, that means that you can have triangles that are right and then isosceles or right and scalene. Now, so you can have a right isosceles triangle or a right scalene triangle. Now this one would be a right isosceles triangle because if these angles are the same, that means that these lengths have to be the same. But I could also make a right triangle like this, and then this would be a right scalene because these two, all three of these sides are actually different lengths. Okay? Now, for an equilateral triangle, since all of the sides are the same length, the angles actually have to be the same as well. So that means that if there is a triangle where all the angles are 60 degrees, it automatically means that it is an equilateral triangle, because if they're the same angles, then that means that the lengths of the sides actually have to be the same as well. So an equilateral triangle can only be acute, and it only can have angles that are 60 degrees. But a right and obtuse triangle can be both isosceles or scalene, because you could have, for instance, this one, since these angles are not the same, it means that it would be scalene. These are going to be slightly different lengths. But if they were the same, and obviously I'm not drawing these perfectly, I don't have a protractor, but let's just say this was 100 and this was 40 and this was 40. That would mean that this and this would be the same, so this would be an obtuse isosceles. Okay? And this would be an obtuse scalene, because these sides would be different. And you could have an acute equilateral, you could have an acute isosceles, or an acute scalene. But equilaterals can only be acute. So this is just a quick overview of how these three types of triangles based on angles relate to the three types of triangles based on lines. This is kind of advanced, so I hope it doesn't confuse anyone. But yeah, I figured I would just touch on how these relate to each other, because I explained them already in some videos. So hopefully this will clear up some things and not confuse anyone.